Hey everybody, welcome back to my channel. This is WireDogSec and I'm back with another video for you guys. Today's video, we are continuing on with TryHackMe pre-security, how the web works, and this room is putting it all together. Learn how all the individual components of the web work together to bring you access to your favorite websites. Without further ado, let's go ahead and dive into it. Task number one, putting it all together. From the previous modules, you'll have learned that quite a lot of things go on behind the scenes when you request a web page in your browser. To summarize, when you request a website, your computer needs to know the server's IP address it talks to. For this, it uses DNS. Your computer then talks to the web server using a special set of commands called the HTTP protocol. The web server then returns HTML, JavaScript, CSS, images, etc., which your browser then uses to correctly format and display the website to you, and has a example of that process right here. Request website in your browser, find web server IP address with DNS, view website, connect to web server. And yes, we've read this, so let's continue on to task number two here. We want to talk about load balancers and other components. Load balancers, when a website's traffic starts getting quite large or is running an application that needs to have high availability, one web server might no longer do the job. Load balancers provide two main features: ensuring high traffic websites can handle the load and providing a failover if a server becomes unresponsive. When you request a website with a load balancer, the load balancer will receive your request first and then forward it to one of the multiple servers behind it. The load balancer uses different algorithms to help it decide which server is best to deal with the request. A couple of examples of these algorithms are round robin, which sends it to each server in turn, or weighted, which checks how many requests a server is currently dealing with and sends it to the least busy server. Load balancers are also perform periodic checks with each server to ensure they are running correctly. This is called a health check. If a server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until it responds appropriately again. And here's a example of it, right? There's the client, which is your machine, going out to these, or the load balancer here, and it's going to load balance them through these particular servers here. So let's go ahead and continue on here. CDN, Content Delivery Networks. A CDN can be an excellent resource for cutting down traffic to a busy website. It allows you to host or static files from your website, such as JavaScript, CSS, images, videos, and host them across thousands of servers all over the world. When a user requests one of the hosted files, the CDN works out where the nearest server is physically located and sends the request there instead of potentially the other side of the world. Databases. Often, websites will need a way of storing information for their users. Web servers can communicate with databases to store and recall data from them. Databases can range from just a simple plain text file up to complex clusters of multiple servers, providing speed and resilience. You'll come across some common databases: MySQL, MS SQL, which is Microsoft SQL, MongoDB, Mongo Database, GraphQL, Postgres, and more. Each has its specific features. WAF, Web Application Firewall. A WAF sits between your web request and the web server. Its primary purpose is to protect the web server from hacking or denial of service attacks. It analyzes the web request for common attack techniques, whether the request is from a real browser rather than a bot. It also checks if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will only allow a certain amount of requests from an IP per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. And here's an example of that: the client, and you have the WAF here, and then behind it are the web servers. All right, answer some question time. What can be used to host static files and speed up clients' visits to websites? Remember, we saw up above that was the CDN, so let's go ahead to put that in there. What does a load balancer perform to make sure a host is still alive? Remember, it does a health check, right? So let's go ahead and type that in here, health check. And what can be used to help against the hacking of a website? Well, as we saw, the last option there was the WAF, the Web Application Firewall. So let's go ahead and type that in there. Now let's continue on to task number three. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. Task number 3, how web servers work. What is a web server? A web server is a software that listens for incoming connections and then utilizes the HTTP protocol to deliver web content to its clients. The most common web server software you'll come across is Apache, Nginx, IIS, and Node.js. A web server delivers files from what's called its root directory, which is defined in the software settings. For example, Nginx and Apache share the same default location of var www html, and Linux operating systems and IIS uses C inetpub www root for Windows operating systems. So for example, if you requested the file www.example.com picture.jpg, it would send the file to var www.html picture.jpg for its local hard drive. Virtual host. Web servers can host multiple websites with different domain names. To achieve this, they use virtual hosts. The web server software checks the host name being requested from the HTTP headers and matches that against its virtual host. The virtual hosts are just text-based configuration files. If it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com being mapped to var www website underscore 1, and 2.com being mapped to var www website underscore 2. There's no limit to the number of different websites you can host on a web server. Static versus dynamic content. Static content, as the name suggests, is content that never changes. Common examples of this are pictures, JavaScript, CSS, etc., but can also include HTML that never changes. Furthermore, these are files that directly served from the web server with no changes made to them. Dynamic content, on the other hand, is content that could change with different requests. For example, a blog. On the homepage of the blog, it will show you the latest entries. If a new entry is created, the homepage is then updated with the latest entry. Or a second example might be a search page on a blog. Depending on the word you search, different results will be displayed. These changes to what you end up seeing are done in what is called the backend with the use of programming and scripting languages. It's called backend because what is being done is all done behind the scenes. You can't view the website's HTML source and see that or what's happening in the backend, while the HTML is the result of the processing from the backend. Everything you see in your browser is called the front end. Scripting and backend languages. There's not much of a limit to what a backend language can achieve, and these are what make a website interactive to the user. Some examples of these languages in no particular order are PHP, Python, Ruby, Node.js, Perl, and many more. These languages can interact with databases, call external services, process data from the user, and so much more. A very basic PHP example of this would be if you requested the website http example.com index.php name equals Atom. If .php was built like this, and there's an example here, it would output the following to the client. There you go, hello Atom. You'll notice that the client doesn't see any PHP code because it's on the back end. This interactivity opens up a lot more security issues or web applications that haven't been created securely as you learn in further modules. What does web server software use to host multiple websites? Well, that's virtual host, right? So virtual host. And the next one says, what is the name of the type of content that can change? Remember, static stays the same and dynamic changes. So there you go. Does the client see the backend code? Well, no, it does not. Answer should be nay because it can't see the backend code. Now let's continue on to task number 4 and wrap it up here. The quiz. Click the view site button on the right using everything you've learned from the other modules, drag and drop the tiles into the correct order of how request to a website works to reveal the flag. When placing a tile in the correct position, it will highlight in green. When a tile is in the wrong spot, it will highlight with red. Make sure not to refresh the page, as it will reset the tiles all to blank again. So let's go ahead and do this. All right, let's see here what we got here. We got 11 steps here. Okay. First thing should be the request here, and then it's going to check your local cache. If this will drag over. After that, it should do the recursive DNS, and then after that, it should be the one right above it, which would be this authoritative DNS. So go ahead and drag and drop that down there. After that, it should start going to this one here, right? Yep. And then the firewall or the WAF. Go ahead and drag this over. There we go. And then load balancers are behind that. And then after that, it should actually hit the web server. There we go. After that, it should do the get request and then talk to the database in the back and then display in your browser. And there we go. Got the correct order. So go ahead and grab this flag out of here. And that should wrap up this video. If you found this video of value, please consider hitting the subscribe button with the notification bell. Hit the like button, comment below your thoughts and opinions. As always, thank you for watching. Have a nice day, and I'll see you later.